How is it going, guys? Welcome back to another Leetcode Daily. Today we have a hard problem making a large island. Um, see, this problem is hard, but once you know the trick, it becomes so easy. Or medium, if you know like the DFSs and BFSs and stuff. If you know your way around that, it becomes a medium. But I didn't know the intuition. I had to look it up. The intuition is like a hint somebody would give at the interview or something. Like it's really. Let's get into it. It says you're given an n times n in the binary matrix. You're allowed to change at most 1 0 to be a 1. So you're only allowed to change one index in this matrix from a 0 to a 1. Return the size of the largest island in grid after applying this operation. An island is 4-directionally connected group of ones, right? So an island basically is all ones. Zeros are water. You can only change 1 0 to be an island, and you want the maximum area of a large island. And to give you the intuition, I'm just going to draw a small drawing right here. If we have, let's say all of these are 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Right? Let's say, let's make this like, let's add this, like, whatever, right? Okay, so which 0 here do you think, if I change to a 1, will give him a maximized island? Right? This one. Where if I change this one to a 1, then all of this is a big island, right? And I meant to put it in the middle for a reason. Because, okay, so in this case, these islands are all connected. So these are all connected together. So the 0 basically just connects to one big island. But I meant there's several cases where it could be like something like this, where there's an island to the right, island to the left, and the 0 connects them both. But the 0 can also connect more than 2 islands together. For example, let's keep on going like this. What if all of this is 0? Let's say 0, 0. Like, let's say like there's ones down below the 0, right? You get what I'm saying? Where it's kind of hard to explain it, but like the 0 has ones below it, right below it, but they're not connected to either this one or this one. Same goes for up. So basically 0 can connect up to 4 islands together. That's what I'm trying to say. Knowing this info, meaning you can literally, all you need to do, if you know the intuition, calculate all the sizes of islands, right? So we have like 4 islands. We calculate the sizes of all of them, and then we're just going to loop over it, the zeros, right? And then try to flip the 0, and then knowingly pre-computed the size of the island, we can get, so we see the 0, right? We get the island to its right, to its left, to its bottom, to its top, if they're different, and then we just sum up all together and get the maximum value. That's basically it. So I start off by having this direction array, 4-direction array. This is the DFS function. I'm going to be labeling every island with 1 key, just because I'm going to keep the sizes in a hash map, and I don't want to keep the individual indexes. It's just less work, so I just had to add the key. You can do like where every index of the island has the same size, but that's just going to be a waste of space. So I'm going to be DFSing. This is basically just a DFS where it checks if it's in boundaries, and if it's not equal to 1. If it's not equal to 1 can mean 2 things. If it is 0, it being 0, which is not an island, or it being already visited. So it has some other key, because I'm gonna replace the key here. So if this like ID is like 5, that means it's visited already, right? Anyways, we set the current cell to a key. So we basically are coloring. We're basically coloring the same islands the same color. And then we start off res equal 1, because the one I'm on has to equal 1 to be able to DFS. And then we go 4 directions, and then we return the res, right? This is going to be the size of this island. So what we do here is we're going to loop. If we find an island, we're going to DFS it, check it out, update the sizes of that key with it, and then increment the ID basically, right? Now what we do is we have this function max area for current. What this does is it takes what we're going to do here is we're initializing res which is going to be equal to the maximum island found if there's sizes. We're starting off with that. Otherwise, it's just going to be 1, because if I was given an array of all zeros, then the maximum island I can get is 1, meaning flipping one index only to a 1. So, and then I'm going to loop over. If it's a 0, if I find a 0, then let's try flipping it. So res is going to be equal to the max res and max area for current RC. What this does is I initialize the current flip as 1 because it's an island now, and I'm just going to keep track of the labels I counted already, so I don't count them again. Checking if it's in bounds and it's not in visit, that means I counted the label. This keeps track of the keys I added. So I'm just going to add this key and I'm going to increment by its size. That means I counted the island, so I don't count it twice, basically. And then I'm going to return the res, which is the size of the island with this flipped, right? And I'm just going to keep track of it and return it. Simple enough. The time complexity of this is definitely O of n times n, which is n squared. Yeah, that's been it, guys, for this one. It's pretty, if you know the intuition, I didn't know it, but once you know it, it's easily solvable. Thank you guys for watching. See you in the next one.